Hello dear students, welcome in this maths class. Let's do this question. This question is taken from class 9 chapter 8 quadrilaterals and this is exercise 8.2. Fourth question is ABCD is a trapezium in which AB parallel to CD. So here ABCD is a trapezium, AB is parallel to CD given. Okay, so BD is a diagonal, right? E is the midpoint of AD, so E here is midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. So from E a line is drawn which is parallel to AB, this is okay, and intersecting BC at F. Show that F is midpoint of BC. So F, we are to prove that F is midpoint of BC. So in this question what is given? ABCD is a trapezium. Trapezium means a quadrilateral in which at least one pair of opposite side is parallel. So in this trapezium AB is parallel to CD given. BD is diagonal and E is midpoint of AD. Okay, E is midpoint of AD. Now this EF is parallel to AB given. These things are given and we need to prove that F is midpoint of BC. So let's start how to do. So first of all you will see in triangle ABD. In ABD triangle if you see E is midpoint of AD and this EF is parallel to AB. Okay, then by converse of midpoint theorem this point, suppose this is G, so G point will be the midpoint of BD. This is converse of midpoint theorem. I want to explain you what is midpoint theorem. Converse of midpoint theorem, it says that if a line is drawn through the midpoint of one side of a triangle, okay, and parallel to another side, always bisect the third side. So here also in triangle ABD, E is midpoint of AD and EG is parallel to AB, so G will be the midpoint of BD. Now G is midpoint of BD we have proved by converse of midpoint theorem. So now come in triangle CDB or BCD triangle. You see in BCD triangle here G is midpoint of BD, we have proved now only, and this GF is parallel to CD because AB is parallel to CD and these three lines are parallel, so GF will also be parallel to CD. So by converse of midpoint theorem F will be midpoint of BC. So again I repeat, in triangle BCD G is midpoint of BD, we proved now earlier. So this GF is parallel to CD. So by converse of midpoint theorem F will be midpoint of BC. So this way we will prove this question. So let's write now. So it's written, given ABCD is a trapezium, AB parallel to CD and E is midpoint of AD given and EF is parallel to AB given. So we have to prove that F is midpoint of BC. This we have to prove. Now prove, how to prove this? See, in triangle ABD, E is midpoint of AD and EF is parallel to AB. So by converse of midpoint theorem G will be midpoint of BD. Okay, so again I want to tell you that what is converse of midpoint theorem. Converse of midpoint theorem says that if in a triangle a line segment through the midpoint of one side of a triangle and parallel to another side, always bisect the third side. So here G will be midpoint of BD. Now again in triangle BCD, this triangle G is midpoint of BD because we have proved now only, and GF is parallel to CD because GF is parallel to AB, so it will be parallel to CD also. So by converse of midpoint theorem again F will be midpoint of BC. So hence proved. This is only to be proved. Thanks for watching.